Now that we know a little bit about these linear equations in two variables, let's talk about how we're going to solve them. That means how we're going to draw a picture of the answer. Okay, we already discussed they're all going to make a line. That's why they're called linear equations. They make a line. And so all I need are 2 points. Right? 2 points. So I've got two methods. I can use the x and y intercepts, and I can use the slope and y-intercept. Okay, so two methods. Pay attention to which method you're asked to use, but on the main thing I want us to know is which method makes it easiest. Okay, and if your x and y is on the same side of the equal sign, usually you're going to use your x and y intercepts. If it's solved for y, you're going to use your slope and y-intercept. Okay, so on this one, even though it tells me use the x and y intercepts, I would do it anyhow. Okay, so I need 2 points. I need 2 points. Okay, and if my x and y is on the same side, the 2 points are my intercepts. I'm going to let x be 0 on one and y be 0 on the other one. So think about this. If x is 0, right, that means this is my equation. And all I have to do is solve one step, right? Divide both sides by -4. So y is 12 divided by -4, -3. Okay, cool. That's not too bad. What if y is 0? Then that means that's gone. And all I have to do is divide by 3. Oh, 12 divided by 3 is 4. And there's my 2 points. Easy peasy, right? Real easy. So 0 and then down 3. And then 1, 2, 3, 4 and 0. Don't go up or down at all. And just draw a line through them. Your lines have to have arrows on either end. It means it goes forever. It's a different thing, which you'll talk about in later math classes. We won't, but if you don't have an arrow, that means something specific. So you gotta have the arrows on both ends. Okay, now remember we talked about last time, if my equation is solved for y, this is my slope. So I know that my slope in this case is 2, and anytime I'm talking about slope, to use, not to leave as an answer, but if I'm using it, I want to see my rise over run. I want 2 numbers. So when it's solved for y, this is my slope, and this number is my y-intercept. Y-intercept. It's on the y-axis. The x is 0 and the y is 3. So that means I have a point. 0, 3, 1, 2, 3. And if I have a slope, I have dozens of points really quick, because to get another point, all I have to do is go up 2 over 1, up 2 over 1, up 2 over 1, up 2. I can get as many points as I want. Also recognize that -2 over -1, as long as they have the same sign, that's also 2. So I could go down 2, backwards 1, down 2, backwards 1. Anyhow, I get a bunch of points. I only need 2. I'm just doing that for emphasis. Okay, so there's how we are going to graph these linear equations. Find a couple of points, either our intercepts, or if we know the slope and another point. Doesn't even have to be the intercept if I know the slope. But this equation in this form gives me the intercept. Okay. Now, these two, before I talk about them, actually, I'm going to do a couple more examples. Okay, let me see. Pen. Couldn't think of what I needed. Okay, so let's say we had 5x plus 2y equals 10. Okay, because my x and y are on the same side, I'm going to use my intercepts. Let x be 0 and y be 0. So if x is 0, this is gone. Not going to mark it out this time. I'm just going to imagine that's gone. So y has to be 5. And if y is 0, if that's gone, then 5x is 10, so x is 2. And you get 2 points. 0, so I don't go right or left because x comes first, and then up 5, and then over 2, and don't go up or down. Draw a line through them. Imagine that's a straight line. Not too good at drawing a straight line, much less on this contraption. Okay, so what if we had y equals negative 2/3 x minus 1? Hey, if it's solved for y, this is my y-intercept. On the y-axis, I put a point at negative 1. And then my slope is negative 2/3. Now, it's negative, means one of these numbers is negative. Only one. If they were both negative, it'd be positive. So only one is negative. It doesn't matter which one you make negative. And this is y's over x's. So I can either go down 2 first and then a positive 3. Or I could make a positive 2 and a negative 3. Either way, notice it gets me on that line. Okay? Now, what if I had something like this? My x and y is not on the same side and is not solved for y. I can't use either of those. So I've got to put it in a position where I can use either of those. I can either move my x over here, put x and y on the same side, or probably what's easiest is just go ahead and finish solving this for y. Right? So you have y equals, if there's not a number written in front of my x, I know it's a 1. So 1/5 x plus 3. Y-intercept is 3. Slope is 1/5. Rise over run. Y's over x's. So up 1 and then over 1, 2, 3, 4, 5. Draw a line between your 2 points. Okay. Now, let's talk about these 2 equations. Do you notice something different about them than all the other equations we've been talking about since we started talking about graphing? As a matter of fact, the whole reason we changed to graphing is because we said we're going to have an x and a y in our equations now. And this only has an x, and that only has a y. So, I would not know that I needed to graph that unless it told me to graph it. The others, once I see an x and a y in the same equation, I know, oh, graphing. If I don't have an x and a y, I got to be told I'm graphing, or I just solve it, which actually is the first thing I'm going to do anyhow. I'm going to solve this equation. I'm going to subtract 1 from both sides, which means x equals 2 minus 1, 1. Okay? Now, these are special. Remember our 2 special slopes? If our line was horizontal or vertical, I said they were special. Okay? If your slope is 0 or undefined, that's special. If you have just an x or just a y instead of having both of them in the equation, that's special. And I want to just put all that stuff together. Once I see an equation with one letter, I'm like, oh, okay, special. Forget all the other stuff about graphing. This is special. Solve it for the one letter. So here's where x is 1. I'm going to put a mark there. And draw a line it's either got to be vertical or horizontal, and this one to go through the tick mark where X is 1, it's vertical line, right? These are all the same, connected. These are connected. So this one over here, first of all, I have to solve it for y. I already know it's going to be special, right? Only has one letter. So 2y equals -4. Divide by 2. Y equals -2. It's special. And here's where y is -2 right here. That's the little tick mark that says -2. This is my clue to help me remember, oh, this is a horizontal line. Okay, so these special equations, don't forget about them. When you see an equation with one letter in it, it's special, and throw out everything else that you were thinking about graphing. Let's do another one. 5x minus 7 equals 2. Now look, it kind of looks like a regular equation, but I gotta notice, hey, there's only one variable in there. So it's special. Right away I know it's special. Solve for that variable. Let's add 7. So 5x equals 9. Divide by 5. X equals 9/5. Now I probably want that as a mixed number, so I'll know where to put it on my x-axis, because it's telling me x is this, x. So 1 4/5 is like right here. And to make my tick mark where that is on the x-axis, that tells me which direction my line needs to go. Okay, see you next time.